Hi, today I want to talk about linear inequalities. Linear inequalities are very similar to linear equations, except instead of an equal sign, we now have an inequality symbol. The inequality symbols can be read from left to right without any numbers. If you see the point first, that is less than. If you see the open side first, that is greater than. Whenever you see the line underneath it, that means it's also equal to, and it's either less than or equal to, and greater than or equal to. So for instance, x is less than 3 means that any value for x must be true, or any value of x that is true has to be less than the number 3. A solution must make a true statement. Solving inequalities is like solving linear equations. The main difference is we have to be cautious of our inequality symbol when we're performing certain operations. So if I were to ask you to solve x plus 5 is greater than 8, you would solve this as you would x plus 5 is equal to 8 by subtracting 5 from both sides. And x is greater than 3. So any number that is greater than 3 makes this true. Like if I pick 10, 10 plus 5 is 15, and 15 is greater than 8. If I pick a number that's less than 3, it doesn't work, like 0. 0 plus 5 is 5, and 5 is not greater than 8. So it's any range of values above 3, and 3 is not included in this statement. So the only difference between equations and inequalities is when I multiply or divide both sides by a negative. If I do this, I need to flip the direction of the inequality. So I change the inequality direction. For instance, if I have negative 2x is less than 10, I divide both sides by negative 2 to solve. Negative 2 divided by negative 2 is a positive 1. X, 10 divided by negative 2 is negative 5, but I need to change the direction of this to be greater than. And let's think about a number that's greater than 5. 0 is greater than 5. So if I plug in 0 for x into my original equation, negative 2 times 0 has to be less than 10, and 0 is less than 10, so that's true. So I have picked a valid solution set. If I had 2x less than 10, and I divide by 2, I don't flip the inequality. I leave it as is. So a number less than 5 would be 0. It's a great number to try. 2 times 0 is 0. 0 is less than 10. That works. So the only time that you change the inequality direction is if you multiply or divide both sides by a negative. When I want to graph an inequality, I have to pay attention to whether or not the variable is on the left or the right, and whether I'm talking about a less than or equal to. So when I'm graphing, let's say I have x is greater than 3. I check if x is on the left, I can follow the arrow of the inequality. What I mean by that is I'm currently saying greater than, and so I want to head towards the greater than. If x is not on the left, you have to go in the opposite direction. So I set up my number line. I have 3. Nope, I want to start bigger or smaller. 0, 1, 2, 3, 4, 5. So because x is on the left, I can head towards the greater than. And so what I will do is on my graph, I'll go from 3 to the right. And because my inequality is just greater than and not greater than or equal to, I'm going to use a parenthesis to mark that value. Now, if I had x on the right, and I was talking about 2 is less than x, if I graph that, I don't want to go to the left. I actually want to go to the right. And I'm going to show you by picking some values. If I pick a value like 0, right here, 2 is not less than 0. So I don't want to be shading on the left side. I actually want to shade on the right side. So I shade to the right where my solution is true. And again, I use a parenthesis. If I have an inequality where x is less than or equal to some value, when I'm doing my graphing, I set up my inequality. X is on the left, so I can follow my graph to the left or the less than side from 3. But because it is less than or equal to, I don't put a parenthesis, I actually put a bracket. So to generalize, anytime I have less than or greater than, I use a parenthesis. Anytime I have less than or equal to, greater than or equal to, I use brackets.